Hello and welcome you all. This is Professor Rajesh Barapte, a book author of 25 plus engineering books. Dear students, today's topic is initial conditions of a network. It is from the subject electrical circuits for second year ENTC students. Before talking about initial conditions and before solving the numericals related to initial condition, let me explain you what do you mean by initial condition. If it is a resistor, we know that symbol of resistor is like this. There are no initial conditions because resistor is not a storage device. So initial conditions are existing if and only if it is a storage device. That means if it is inductor like this or if it is a capacitor, then there are initial conditions. Now, if we will consider an example of a capacitor, then in case of a capacitor, the charging and discharging is exponential like this. Ideally, we say the charging of capacitor starts from 0, it reaches some value, say V max, where V max is the maximum value, and from this value discharging starts. This is the ideal situation. But discharging of a capacitor takes certain amount of time period. Suppose someone has used the capacitor gets charged up to this value V max, then it will get discharged. It is not yet reached to 0. It is, say this value V max is equals to 5 volt. It get discharged up to 3 volt only. It is not getting discharged up to 0 volt. And meanwhile, some another person started using this capacitor, then the charging will start from 3 volt. It will not start from 0 volt. This is representing an initial conditions. Now mathematically, how to represent it? If you are performing any experiment and if you want to use a counter to count down the time period, then in that case, whenever you start the experiment, the time period is supposed to be t is equals to 0. Just after, suppose there is one switch and you are closing the switch and then you are starting a particular experiment. So when the switch is closed, that time period is t is equals to 0. Now, how to denote the time period before closing of a switch? Before closing of a switch, this time period is t less than 0. In this subject, it is denoted by t is equals to 0 minus. So, in another language, if you are performing some experiment at 11 a.m., then t is equals to 0 means 11 a.m. Just before this time, that means 10:59 a.m. Whatever the condition is existing, that is denoted by t is equals to 0 minus. Now, just after starting an experiment, that means you are starting experiment at 11 a.m. Just after this, suppose I want to count what will be the condition at 11:01 a.m. This time period is t greater than 0. In this subject, it is denoted by t is equals to 0 plus. So, how to memorize the things in a simple language? T is equals to 0 is an instant at which you are performing some experiment, you are performing some operations. T is equals to 0 minus represents the instant, time instant before closing a particular switch or before starting a particular experiment. T is equals to 0 plus is an instant just after starting a particular thing, particular experiment. Now there is one more term that is denoted by t is equals to infinity. T is equals to infinity means you are performing a particular experiment for longer time period. Let us say from 11 a.m. to 12 noon. So this is 1 hour time period, which is longer time period compared to seconds or milliseconds. Then it is denoted by t is equals to infinity, and mathematical term related to this is steady state condition. So steady state condition means the condition which you will get after performing experiment for a very long time period. Now, this table is very much important as far as this initial conditions are concerned. What this table indicates? Every element has some initial conditions. As I mentioned, resistor is not a storage element, so there are no initial conditions for the resistor. So I have drawn the symbol of resistor. T is equals to 0 means what? It is the time period at which you have closed the particular switch and you have started some experiment, that is t is equals to 0. T is equals to infinity means you have started performing some experiment and you are continuing it ideally for infinity time period, that is t is equals to infinity, and it is also known as steady state condition. So in case of resistor, the things remains as it is. If it is inductor, this is the symbol of inductor. Now do remember one basic thing. Inductor is a current operating device, capacitor is a voltage operating device. But in case of inductor as well as capacitor, initial conditions are present. So if it is inductor, at t is equals to 0, it is represented by open circuit. At t is equals to infinity, it is represented by short circuit. Very simple, the things are opposite to each other. At 0, it is open circuit. At infinity, it is short circuit. Then if suppose some initial current is present in case of inductor, that is denoted by I0, like in this case, this is the case of capacitor. As I said, capacitor get discharged up to 3 volt, it is not get discharged up to 0, and you started performing the experiment, then this 3 volt is known as initial voltage of a capacitor. Likewise, in case of inductor, it is denoted, it is called as initial current of a inductor. So if suppose I0 is initial current in the inductor, then simply it is denoted by the current source of value I0, which is for t is equals to 0, and for t is equals to infinity, it is same current source I0 in parallel with short circuit. You need to remember this symbol, it is drawn over here, it is in parallel with I0. Then for a capacitor, now how to memorize this table? Very simple tricks. Resistor remains as it is. For inductor, at 0 it is open circuit, at infinity it is opposite to this, that means short circuit. Then for initial current, whatever value is there, I0, it is represented by current source. This symbol I will draw it in parallel, that is in parallel with I0 I will draw a short circuit line. This is for inductor. For capacitor, make the thing simple. Whatever things you will be memorizing for inductor, write it in opposite way. That means at t is equals to 0, inductor is open circuit, capacitor is short circuit. At t is equals to 0, inductor, at t is equals to infinity, inductor is short circuit, capacitor is open circuit. Exactly opposite. In case of V0, V0 is what? Some initial voltage present across the capacitor. It is represented by the voltage source. What I said, capacitor is a voltage operating device, so it is represented by voltage source. Inductor is a current operating device, so it is represented by the current source. Now, same way, if certain initial voltage is present, at t is equals to infinity, that voltage V0 is drawn in series with open circuit. To make the things more simple, whenever it is open circuit, draw it in series. Whenever it is short circuit like this, draw it in parallel. So these are some initial conditions for resistor, inductor and capacitor. As I mentioned, this part is very, very important. Now, let us solve few numericals to get an idea about these initial conditions. We'll solve few numericals. I will be telling you simple tricks to solve the numericals related to initial condition. The question is, in the following network, switch K is the notation used for switch, this is the switch in the given diagram, is opened at t is equals to 0. So t is equals to 0 is the instant at which switch is opened. Find V dV by dt and d square V by dt square at t is equals to 0 plus. Just now I explained you concept. T is equals to 0 plus is an instant just after operating the switch, whether it is opening or closing. So from the given question, you can easily predict switch K is opened at t is equals to 0. First step 1 is we need to calculate if there is any initial current for the inductor. In the given diagram, there is no capacitor. There is an inductor. In case of inductor, we need to calculate initial current. If it is capacitor, we would have calculated initial voltage. So in case of inductor, I need to calculate before operating the switch whether there were some initial conditions or not. How to do it? Clearly it is mentioned switch K is opened at t is equals to 0. That means before t is equals to 0, switch was closed. And because of this only, it is written switch K is opened at t is equals to 0. So before t is equals to 0, switch was closed like this. So it clearly indicates, see, in the given question, there is only one current source. And there are three branches. One, this branch containing a switch, then resistor, and then an inductor. This is the voltage we marked in the question. So if switch is closed before t is equals to 0, then there is a short circuit in parallel with this current source. Do remember one basic fundamental thing. Whenever there is short circuit in parallel with anything, any element, then that element becomes redundant. In another language, the switch was closed before t is equals to 0. So entire current passes through short circuit branch, because the tendency of current is always and always to flow through the branch where there is a minimum resistance. Minimum resistance means short circuit. So entire current will flow through this. Now at this point, voltage V is marked. Indirectly, we know that the bottom line of circuit indicates the ground connection. So this voltage is same as the voltage at this point, as well as it is same as voltage at this point. In another language, voltage V, we can say it is the voltage drop across 10 ohm. But as we discussed, when it becomes short circuited, when switch is closed, it is like a simple wire. Entire current flows through this short circuit. No current flows through 10 ohm and 1 Henry. Therefore, there is no initial current passing through the inductor. This initial current is denoted by notation I0. So I am writing I0 is equals to 0, because initially the entire current was flowing through this switch, through the short circuits. No current was passing through this inductor. So I0 is equals to 0. Now, in the question it is asked to calculate V and these two values at t is equals to 0 plus. Now, at t is equals to 0, switch K is open. That means for 0 plus, switch remains open. So now I will do the calculation for step 2. What you are supposed to do in step 2? In step 2, perform the actual operation. That means switch is opened at t is equals to 0. So switch is opened like this. And I am doing calculation at t is equals to 0 plus. That means just after opening the switch. So switch K is opened. So this is open circuit. Now no current will flow through this. So entire current 10 ampere will flow like this. This current will pass through this resistor and through the inductor. Now here for inductor you need to refer the table which just now we discussed. So at t is equals to 0, what is an equivalent circuit for the inductor? At t is equals to 0, according to the table we discussed, inductor acts as open circuit. So I will remove this inductor and I will mark it as open circuit. Now the diagram is very simple. This is open circuit, last branch is open circuit. This is happening at t is equals to 0 plus. So at t is equals to 0, entire current of 10 amperes from this current source will flow through this 10 ohm. So voltage across 10 ohm, that I will denote it by V. It is given in the question. This is same as the voltage across 10 ohm. Using Ohm's law, V is equals to IR. So in this case, I is 10 amperes into resistance is 10 amperes. So it is 100. In particular, this is the voltage at t is equals to 0 plus. So this voltage is denoted by V of 0 plus. It is read like this: voltage at t is equals to 0 plus, V of 0 plus, which is equals to 100 volt. This is the value of V of 0 plus. Now let us calculate dV by dt and d square V by dt square. So we have calculated value of V at t is equals to 0 plus. It is denoted by V of 0 plus, which is 100, and its voltage, so its unit is volt, 100 volts. Now, for calculation of dV by dt and d square V by dt square, we need to consider the condition t greater than 0. T greater than 0 is what? You are performing experiment for longer time period, whereas t is equals to 0 plus is what? Just after few seconds of starting the experiment. So for t greater than 0, switch is open, because it is mentioned switch is already open at t is equals to 0. So for t greater than 0, switch is open, current source remains as it is. Now this current 10 ampere will flow like this, but this is open circuited, so current flows up to this point. This is again 10 amperes. Some of the current will pass through this resistor, remaining current will pass through this inductor. I will denote inductor current by IL. This resistance current current through resistance by IR. So simply we can write the equation 10 is equals to IR plus IL. Now this 10 remains as it is. IR is the current passing through resistor. So we have the Ohm's law, I is equals to V upon R. So I will write this equation as V upon value of R is 10 ohm, V upon 10 plus IL, current passing through inductor. Now remember this formula. This is the formula which represents current through the inductor. It is IL, which is equals to 1 by L. L is the value of inductance. Integration of V dt. V is the voltage across inductor. So in this case, this formula is 1 by L. L means 1 Henry. So 1 by 1 integration V dt. Now, without thinking, what do you need to calculate, whether dV by dt or d square V by dt square, whatever it is, it contains a derivative. That means I need to differentiate both sides. So next step is differentiate both sides. One more important thing. If you take derivative of some integration term, derivative and integration are exactly opposite to each other. So if integration term is there and you are taking a derivative, integration gets cancelled. Now look at this equation. At LHS we have 10, which is constant term. Derivative of constant is 0. So derivative of 10 is 0. This 1 by 10, it is V by 10. V is voltage. So I have written is 1 by 10 into V, but I am taking derivative. So it is dV by dt. It is dV by dt. Because 1 by 10 is constant, it is taken out. 1 by 1 is 1. This integration gets cancelled. So I will simply write it, denote it by V. Integration and derivative gets cancelled. Now look at the given question. It is asked to calculate dV by dt at t is equals to 0 plus. So next step I will be writing it like this, at t is equals to 0 plus. So how to denote this equation? The 0 at the LHS remains as it is, 1 by 10 as it is, d by dt of V0 plus. In place of V I am putting V0 plus, plus second term. In place of V, I need to denote it by V of 0 plus. Now, very simple logic. I need value of d by dt of V0 plus. So, let us rearrange the equation. So, I will write it like this. 1 by 10 d by dt of V0 plus is equals to minus V0 plus. What I did, I transferred this term at the LHS and equation is exchanged. I mean, RHS side is written at LHS and vice versa. Then transfer this 1 by 10 at the RHS side. Therefore, d by dt of V0 plus is equals to minus 10 V of 0 plus. We have the value of V of 0 plus. Just now we calculated it. It is 100. So if I will put this value in place of V0 plus, therefore d by dt of V0 plus is equals to this minus 10 into this value 100. So it is minus 1000. How to write the unit? You don't have to mug up the unit. Make the thing simple. It is d by dt of V. V is the voltage. So in the numerator we have volts. So I am writing volt divided by. In the denominator I have t time period. So it is volts per second. So answer of d by dt of V0 plus is minus 1000 volts per second. Now last part is we have to calculate d square V by dt square. We have already derived the things, solved the things up to this value d by dt of V0 plus. This answer we have already generated. Now let us set this equation as equation 1. How to think? Now we want d square by dt square. So differentiate both sides of equation 1 because I need d square by dt square. So if you again take the derivative of both sides of equation 1, then LHS is 0. So derivative of it becomes 0. 1 by 10 as it is. This becomes d square by dt square of V of 0 plus d by dt of V of 0 plus. What I did, I have taken differentiation of both sides of equation 1. Now I want d square by dt square. So let us rearrange the terms. This equation can be simplified as 1 by 10 d square by dt square of v of 0 plus is equals to, I will transfer this term at the LHS, so it becomes negative, minus d by dt of v of 0 plus. I have transferred this term at the LHS and only interchanged the LHS and RHS. So next step is transfer this 1 by 10 term at the RHS. So I will write it like this, d square by dt square of v of 0 plus is equals to minus 10 d by dt of v of 0 plus. We have the value of d by dt of v of 0 plus, that is minus 1000. So it becomes minus 10 into minus 1000, that is equals to plus 10,000. Minus of minus become plus. How to write the unit? It is d square v of dt square. So it is whole square per second square. Or simply you can write whole per second square. Not necessary to write whole square. So it is d square by dt square is of v of 0 plus is 10,000 wholes per second square. Now to get more idea, let us solve one more numerical. K is closed at t is equals to 0. Switch is closed at t is equals to 0. Find I di by dt d square I by dt square at t is equals to 0 plus. This is the switch shown in the diagram. Like the previous sum, in step 1 you need to calculate whether there is some initial condition existing across the element. Now there is inductor as well as capacitor. In case of capacitor we need to calculate initial voltage. In case of inductor we need to calculate initial current. But in the present numerical the things are pretty simple. Switch is closed at t is equals to 0. That means for t less than 0 or before t is equals to 0, the switch will be open. So if switch is open, this 10 volt will not be connected to this remaining circuit. So initial current through inductor, that is I0 is equals to 0. Initial voltage across capacitor is equals to 0. You can well verify it by using the table of initial conditions we have already discussed. At t is equals to 0 plus, inductor will be open circuit, capacitor will be short circuit. So if I will draw this part only, then this will be open circuit and capacitor will be short circuit like this. Due to open circuit, there won't be any flow of current through this branch, that means through the inductor and capacitor. So initial conditions for inductor and capacitor are 0. This is step 1. Now step 2. Make the thing simple now. There is only one source. Step 2 means what we are supposed to do. For t is equals to 0 plus, that means after operating the switch. In this numerical, after operating the switch means what? If the switch is closed. So if the switch is closed, I will show the diagram like this. This is now indicating the switch is closed. So 10 volt is connected across entire circuit. This 10 volt is the voltage source. So some voltage drop will be across resistor, that is VR. Then some voltage drop will be across inductor, that is VL. Some voltage drop will be across capacitor, that is VC. Now you need to remember these two formulae. One is voltage across inductor is L di by dt. Second, voltage across capacitor is 1 by C integration 0 to t I dt. Now, for step 2, I will write the simple equation like this. 10 is equals to VR, voltage across resistor. We know V is equals to I into R according to Ohm's law. Only difference is here suffix R is used, which indicates voltage across resistor. So this 10 remains as it is equals to voltage across resistor is according to this formula I. So I will write small I into R, that is I into 10 plus VL is L di by dt, L di by dt. Value of L is value of inductor, that is 1 Henry. So I am directly putting this value, it is 1 plus 1 by C, voltage across capacitor, 1 by C, value of C is 1 farad. So it is 1 upon 1 integration 0 to t I dt. This is the equation I have written by considering one voltage source and the voltage drop across all the elements. So this is the equation. Now how to think? Initially it is asked to calculate I, that is the value of current. So we just now discussed I0 is equals to 0 because at t is equals to 0 plus, this was open circuited, it was short circuited, so initial current is 0. Next I need to calculate di by dt. This equation already contains di by dt, so I have to only think of this integration term. If this will vanish, then I will get ready-made answer of di by dt. Say this is equation number 1. Now before taking a derivative, see, like the previous sum, if you directly take derivative of equation 1, you will get d square I by dt square. So I will tell you one more simple technique. Directly write like this, at t is equals to 0 plus. So wherever t is there, I will put the value t is equals to 0 plus, 10 remains as it is. So I will write this current as I of 0 plus into 10 plus 1 d by dt of I of 0 plus 1 by 1 is 1, integration from 0 to 0 plus. So what I am doing? I am doing calculation at t is equals to 0 plus. So wherever t is there, I have written 0 plus I of 0 plus dt. In place of I am writing I of 0 plus. Now, very simple mathematical identity. If you are performing integration from 0 to 0 plus, that means approximately 0 to 0. So if lower and upper limits are same, and integration gets cancelled. Answer of integration is 0. So this term gets neglected automatically. Now I of 0 plus, that is initial current through the circuit, is 0. Just now we discussed. So this term again becomes 0. So simply I can write it like this. 10 is equals to, this term gets vanished because I of 0 plus means initial current, which is already 0. So I will get the answer. It is 1 d by dt of I of 0 plus. Therefore simple d by dt of I or I of 0 plus is equals to 10. How to write the unit? It is current upon time. So it is ampere per second. Now the calculation of last part, that is d square I by dt square. To do this calculation, consider now equation 1, which we have already obtained. So take derivative of equation 1 just to cancel out this integration term. So if you take derivative of equation 1, then derivative of 10 becomes 0, it is constant term. So this is I into 10, I will write it as 10 d by dt of I plus 1, it is constant, so it remains as it is. This becomes d square I by dt square plus integration and derivative gets cancelled like the previous sum. I will write only I or I of t, anything will do. Now we want to do the calculation for 0 plus. So for 0 plus, I will write it like this. 0 is equals to 10 d by dt of I of 0 plus. In place of I am writing I of 0 plus 1. You can well omit it. D square by dt square of I of 0 plus I of 0 plus. Now the term I of 0 plus is I0, that is initial current. We discussed it is 0, so it gets eliminated from this equation. I can well write this as, therefore d square by dt square of I of 0 plus is equals to minus 10 d by dt of I of 0 plus. I have simply transformed this term at the LHS. Now we have the value of d by dt of I of 0 plus, that is equals to 10. So in this place I will put the value 10. So final answer will be d square by dt square I of 0 plus is equals to minus 10 into 10, that is equals to minus 100. It is current upon time square, so it is ampere per second square. This is the final answer. Dear students, this is the way how to solve the numericals as far as the initial conditions are concerned. So let us end the session today itself. Thank you for watching this video. Thanks a lot.